Okay, this is the M1 paper from January 2023. It's question number 6. You're going to need to read through this question. It's all here. But when you do read through the question, as soon as we see that there's a constant speed, which means there's no acceleration, so this means that this is a statics question. Forces are in equilibrium here. So yeah, just have a quick read through of it or pause the video. What I'm going to do is I'm going to draw out a force diagram and then set up some equations. There'll be no overall forces acting parallel and perpendicular to this bank. So let's make a start then. We've got a situation where we've got this particle and we've got a resistance of 900 newtons going that way. But then we've got our 500 newtons acting here. And we've got a force that we don't know, an unknown force, here, P, acting in that direction. And what we know is that this angle here is 40 degrees and this angle here is alpha. So just in terms of keeping the diagrams apart, what I'm going to do when I resolve these two forces is I'm actually going to resolve, obviously, parallel and perpendicular to the riverbank. So when I do that, I'm going to have my triangle going there simply because I can't have in that space there. There's two of them that might want to be there. So for this situation, if this is 40, that means that that's 50 there, and that's 50. Hopefully you've got no problems with seeing this is 500 cos 50, and this is 500 sine 50. If we do exactly the same thing with our P, then what we're going to have is, well, if that angle there is alpha, then that angle there is alpha. So I'm going to have P sine alpha going down there and P cos alpha going in that direction. So most of the work's been done in doing that. Remember, constant acceleration, constant velocity equals no acceleration. So all we're going to do, may as well just put the riverbank on just so that it's clear where the riverbank is. This is the river bank in that direction there. There's a riverbank on either side. So if we've got that situation, then I'm going to be resolving in a minute. So I just tidied that up. I'm going to be resolving perpendicular to the riverbank and parallel to the riverbank. If you have a quick inspection of this, it's not really going to make any difference which way round we go. If we go perpendicular to the riverbank, we're going to have those two forces, so they're going to be equal to each other. And when we go parallel to the riverbank, we're going to have those three forces. But either way, I'm going to get P cos theta and P sine theta, and then need to try and tidy those up. So just tell the examiner what you're actually doing. I'm going to say resolve parallel to the riverbank. So if I'm going parallel to the riverbank, I've got 900, 500 sine 50, and P cos alpha. So I've got that 900 is equal to 500 sine 50 plus P cos alpha there. I'm going to call that equation 1 because I know I'm going to have to do some work with that. Then if I resolve perpendicular to the riverbank. Handwriting is awful there, but it's good enough to get by here. We're going to get that 500 cos 50 balances out with P sine alpha. They're equal to each other. So if you've done any questions on this out of the textbook, we know this is one of our classic situations here where I've got P sine and P cos here. So the quickest way of tidying these two up is if you divide them. So first of all, let's just take number 1 and make it actually P cos. So from 1, I'll get that P cos alpha is equal to 900 minus 500 sine 50. Just call that equation 3 for a second. Simply so I'm going to explain what I'm going to do. I'm now going to do equation 2 divided by equation 3. If I do equation 2 divided by equation 3, I get P sine alpha over P cos alpha, which I've done lots of times in the past doing questions out of the exercise book. That works out to be equal to 500 cos 50 all over 900 minus 500 sine 50. And then the key to this is the p's cancel and the sine over cos works out to be equal to tan. So we get that tan alpha is equal to this same thing here. And so alpha, just tan to the minus 1 of that, and alpha works out to be equal to 32 degrees. Did it say anything about the degree of accuracy? It didn't, so I'm going to do it to nearest degree there. And once I've got that, I can then work out P by putting it into either one. I'm going to say P sine 32 is equal to 500 cos 50, so P is equal to 500 cos 50, all divided by sine 32. So P works out to be equal to, in this case, 610 newtons. And I've done that to 2 significant figures. So yeah, relatively unusual question in terms of the diagram, but all the skills were fairly familiar to us, so we shouldn't have had too many problems with that one. Okay, hopefully that all makes sense to you.